Here is the question. Question says a box of mass m1, this one, is kept on a table and is connected with another block of mass m2, which is here, connected with this string. As shown, find the acceleration of the two blocks and the tension in the string. All the surfaces are frictionless and the value of g is 10 meter per second square. Okay, so first of all, we have to apply all these real forces on the blocks of the question. So first of all, we will go for block M1. For block M1, there 1 is mass times gravitational acceleration, which is its weight m1g, and next is the normal reaction force n offered by the table on blocks m1, and tension T in the string, which is always move farther from the considering object. In this case, our considering object is block m1. So the direction will be moving away for the tension from this box m1. Now, for m2, m2g, its weight downwards, tension T upwards by upwards, because now the considering object is m2. And for m2, the direction of tension in the string will be moving away from m2. So it's upwards. A little consideration will show us that as m2 descends downwards, the box m1 or the block m1 will move rightwards. As the string is inextensible and unstretchable, so the acceleration of m1 and m2 will be equal in magnitude. So let this acceleration be a. Now we will have to construct equations. Next, construct equation for first for box m1. Now here n is equals to mg. Why? Because the direction of motion of the block m1 is in horizontal direction. So if the box m1 is moving in horizontal direction, it means the vertical forces are balanced. Hence, n is equal to m1g. Next equation is on block m1 is T is equals to m1a. Why? Because the resultant of all the forces in the horizontal direction on block m1 is only T, which is in the direction of plus x-axis. So the resultant is T itself here, because no other force is acting on the x-axis. So T is equals to m1. Why m1a? Because NLM says that all the resultant forces must equal to mass times of the acceleration of the object. Okay. Now, for m2, we know that the m2g is in downward direction and T is in upward direction, and still it is descending, means it is moving in the direction of m2g. It means m2g is greater than T, and there is no motion on the horizontal axis. The motion of m2 is only on the vertical axis. So the resultant force on vertical axis will be m2g minus T. Why? Because our common sense says that m2g must be greater than T, because it is descending in the direction of m2g. So, okay. So resultant force is m2g minus t. So this resultant force must be mass times of its acceleration, means m2a. Now, from these two equations, we can solve for tension and acceleration. So, for acceleration, solving equation second and equation third, we get m2g is equals to m1 plus m2 into a, and hence acceleration we get here is m2g upon m1 plus m2. Now, if we substitute the value of a into either of the equation, we get, let's say in equation 1, we get t is equal to m1 m2g upon m1 plus m2. The concept or the point where a student generally stuck is to formation of the equation and the presentation of the forces. So I think it is covered in a broader way in these questions. If you like the explanation, then please like and subscribe our channel. Thank you.